So what would that be? So if you look at the source code, this is basically a Flask application. You can see it imports from Flask, Python threads. There's some built-in things here. You can actually run this on Flask, right? So take this file, and if you have Flask installed, you are able to run it. And then you can see that there is a slash route registered here with the post method, allowing the user to specify a password. And then once the password is specified, it will essentially check the password. So by checking the password, this particular specific implementation will check the password by taking 4 slices. So the password is it's a 12-digit. Is it number? I think it's just a number. Yeah, it's a 12-digit number. For example, this is a valid password. 3 ones, 2 threes, and then 3 fours, right? So this is 12 digits, numbers only. It can have zeros as well, right? So the password can be 000, and so on. It will take 4 slices. The first 3 characters, then the next 3, the third, and then the last 3. And then what you have to exploit here is that when it verifies the password, you can see that it will verify it chunk by chunk. And it does by calling this verify chunk, which is contacting a chunk server. And whenever you contact a remote server, you expect it that will have some sort of additional latency. It's not verifying it in the same code, but it does something where each chunk is being verified remotely. Right, you can see that we have also the code for the password-db chunk server. So you can again run this one with Flask. How it verifies the chunk is easy, right? So it has a verified chunk, and if the chunk is not the same as what the chunk server has saved, then you will abort. Otherwise, you return an empty string. You don't have to worry about this. This only matters that the chunk server is called from these lines, and this is the important part. So the password is supplied, and then if the first part of the password is correct, then what happens is you run verify chunk twice, right? Because you run it first here, and if that's correct, then you go to the second one, and then you run this line. So you first did a remote call to this chunk server, and you only go further if the first piece was correct. Meaning that there is a latency difference between having the first piece being incorrect and the other 3 we don't care, and the first piece being correct and whatever is the other 3 pieces. And you can see where it's going, right? So if you're able to measure the latency it takes for this entire password verification to return, you will be able to know if your code has passed this line, meaning that the first piece, first chunk is correct, or it hasn't passed that line. Because if it did, then essentially verified chunk would run twice. Imagine that verified chunk has 100 milliseconds of latency. So if the passwords if the first slice is incorrect, then it would return you with 100 milliseconds. of response time. But if the first slice is correct, then it would return you 200 because it ran this one. And then because we didn't abort, we'll go and verify the second chunk. We don't care at this point what the second chunk is. We just know that the first chunk was correct. And then essentially you're cracking the password chunk by chunk. So first the first chunk, and then when you know that one, then you do the exact same thing by enumerating over the second chunk. Because if you see here, this password is 12 digits. Each digit has 10 combinations. So 2 to the power of 10 is a big number. If you would want to brute force this password without taking these chunks into account, you will be probably running this whole thing for months. You can parallelize it. There are lots of compute resources, might be able to do it in a few hours, but there are lots of combinations here, so you cannot do it. Although if you only have to here try 999 different combinations, and then you get the one that's the right one for the chunk, and then you move to the next one, and the next one, and the next one, you're able to solve this in less than an hour. And if you parallelize it, you can actually solve this in a minute. So if you want to thread this up and solve it in parallel, you can solve it in less time. Yeah, so let's see how we would do it. Yep, it's infeasible to brute force all 10 to the power of 12. So how would you do it, right? First of all, let's make sure that you can invoke and this endpoint and call it from curl. And we can, right? So invalid password. Now we're gonna focus on these ones. And let's try to crack the first chunk. What I'm gonna do here is first generate numbers. I'm gonna be lazy here, and I don't want to deal with some format strings. So I'm just gonna generate from 100 to 999. If your password is less than 100, you're gonna miss it. I'm taking a risk here that hopefully the first chunk is gonna be larger than 100. Because this is just a demonstration here. I think that's the correct syntax, but we'll see in a sec. So in I will sequence from 100 to 999. I'll put this into the password for the first chunk. Oh, okay, yes, and in order to know what we're doing, we're gonna also echo out the password to see what's being evaluated. Okay, we missed the most important part, to actually print out some timing of response time. So you can time your curl request. So do that. And I think it's running. Now what we're looking at is an anomaly, essentially a much higher latency than the rest. So you can see that on average, these requests are around 360 Is it millisec? Yes, 360 millisec. And the anomaly would be approximately 100 millisec more. Now, we cannot tell you exactly, also because we don't know the way. It depends on lots of network conditions and how quick our verified chunk verifier server is. But you will definitely see it. You definitely see one that will stand out and will be much higher than the rest. So that's what we're looking for. That was a 400. That was a 420 somewhere, 427. So this could be suspicious, but let's look. And again, making a big assumption here that I'm only checking after like from 100. You should be checking from 000 to 999. This is the curl way. It's much easier to do it in Python, and I'll show you which library to use. I'm just checking here with my eyes if there's anything that stands out in the latency. Another thing to consider here, make sure your network connection is stable. If your network connection is on a Wi-Fi that's not stable, you will have all sorts of variations between your response times, even for the cases where there shouldn't be any difference. So if these numbers are all over the place, then check your network connectivity to make sure, for example, you have a cabled connection, not Wi-Fi. And if it's really bad, just get a VM on Amazon or Google Colab, somewhere where you can run some Python code or some Bash, whatever you implement this thing in, where it's a more stable connectivity. So let's see, 3 on up, and that's it. That's an outlier for sure. You can see it's a 590 millisecond instead of 340, so at least 200 millisecond difference in this case. And I'm happy with this. This is going to be my first password, basically 369. Okay, so how do we know? How do we kill this? 369, meaning that you have suspicion that we got the first chunk. 369. And then we go and similarly crack the second chunk. And we know we are in the right territory because now everything is incremented here in terms of latency response times, because now we are cracking the second chunk. So we can be sure that the first chunk is correct because the latencies are around 600 milliseconds. That's about it. That's how you crack through the code and get the password. Once you have the password, you call the endpoint and you will get the flag. That's on PasswordDB. I want to show you what we recommend you to use. It's Python requests. So basically doing this in Python, easier, quicker, nicer. And the response object has elapsed. This property, elapsed. Try it. What does this do? Perfect, yeah. Where do you run this? Get your own Python. Okay, yeah, it already ran, right? This is nice. Can we solve PasswordDB from here? You can technically, by the way, solve it from here if you can get a server to actually have this code run. It run on. It doesn't look like when I type it would run automatically, but it's cool. You can do it here. It's going to be a post method, right? So request.post, and when you do a post, you would have to supply the password, right? So the password here supplied in a data field in curl for -d. For Python post, it would be something like this. Requests.post URL data equals a key is password, and the value is going to be this 12-digit password. Yeah. Yeah, I think if you get here a Python surround, Shriver is free, get started for free, and you can even solve it here. Yeah, a million ways to solve it. All right. So that's on PasswordDB. And the other three, we will, again, please ask questions, and we'll help you there. Right. That's for the small CTF4 help. Don't hesitate to reach out.